progress.
Okay, my project is like trying to find out the precipitation, evapotranspiration, and vegetation indices like NDVI and EVI, especially focusing on Logan River watershed in the 10 years period, just to know what's the condition of the vegetation over there, and and also quantifying the precipitation and ET to get or calculate the water balance in this waterside area, especially in the waterside area. So, so yeah, especially it's a little blurry because of the white background. So, Logan River waterside, it's just like the watershed that covers or that drains headwaters near the Utah-Idaho border. So, and in the ongoing Western water crisis, especially because of the need for the water optimization, I just want to find out what's the condition, especially that leads to the potential drought in the Logan River basin. And in here, we are trying to quantify the precipitation and evapotranspiration uh, to be more precise in the 10-year period and calculating water balance. And at last, we are just uh, I've tried to find out the vegetation indices like NDVI and EVI, and just trying to make a conclusion that can be made from this project. So that's my major objectives and what I'm just trying to do in the water side that I've said earlier. So these two are my major objectives. And what I did, like in a time series plot. So it goes all the way from the 2010 to 2020. Uh, in the watershed area, I'm just trying to get what's the mean monthly precipitation. So over here, I just got the save file from the StreamStats of USGS website and make it as an asset in the Google Earth Engine. And what I did, like I did some coding using for the precipitations, I just used the CHIRF CHIRPS data set and just to know the condition of the precipitation all the way from the 2010 to 2020. So January of 2010 to December of 2020. And this is how the false soil is so from the precipitation in the water set. And in the time series, it's something like this. So it's just like the parameters that will be useful for getting the water balance in the low and water state area. And another one is the evapotranspiration. So for the evapotranspiration, I use the Morris 16 dataset and I did the analysis in the Jupyter notebook and just got the false color just like this. And since I used the different palette like the yellow, blue, green, white, and here you can see the variation of the UT in the water. And I also took the time scale analysis all the way from the 2010 to 2020. And the graph, it's the mean monthly evapotranspiration. And it's on likewise. And the next one, what I did, like I in the same time frame, I just tried to compare the precipitation and ET in the Logan River watershed all the way from the 2010 to 2020. And it looks like the red one is the precipitation and the evapotranspiration is the orange one. So it looks like the precipitation had exceeded the evapotranspiration in most of the time. So because in the water balance, we got to know like water balance by taking the change in soil storage and considering the runoff at the other side of the equation, we can just know that like water balance can be estimated by subtracting the evapotranspiration from the precipitation. So it looks like there is a, since the precipitation is happening more than the ET, so it's less out than the less in. So it looks like the water is more entering inside the water set than it's going out in the long run. So I also calculate the vegetation indices like NDVI, and this is the false correlation of the NDVI taken from the Landsat age. And what I did, like I found out that I have tried to do. So over here, the green part are just like the more greener vegetation. That's it. So, and this is the time series frame from the 2010 to 2020. And so it looks like there is some, the pattern is showing up here, especially maybe we can just something like because of the drying seasons or in the wet seasons. So it's going up and down, up and down. It looks like it's giving a pattern. And the greenness inside the watershed Logan River watershed area. The other one is I also calculated the EVI, and it's the false origin of EVI. So it also so I also use the Landsat page just to quantify the EVI. And because the way of calculating the two indices is kind of different, right? So that's why we're just getting the different color in between the NDVI and EVI. And it's the graph of the EVI, and um, it's also showing from the 2010 to 2020, and we can see the pattern over here in the EVI. And the other one is like we are comparing, we are putting the NDVI and EVI in the same time frame in the Logan watershed all the way from the 2010 January to the December of 2020. What we are seeing over here is like NDVI is seeing more than the EVI, and there's some pattern just going ups and downs, and that's clear. And especially this type. So when the NDVI index is going down, we can conclude that on the especially in the dry seasons where the greenness in the vegetation is going down, and it's up, going upwards in the wet seasons, where the greenness of the vegetation is going up. And so from this, so what we can just discuss about from this things like, okay, the observed pattern depicts that the precipitation exceeds evapotranspiration most of the time. So uh, and it helps to determine the water balance and finding out the water that's stored in the wet and dry season that's used by the forest and the cropland. So we got to see distinct patterns in NDVI and EVI. So it's just showing like the early dry and wet seasons. So I was just using the data's from, so it's like the 10-year data from the 2010 and 2020. So in order to be more precise and in order to see whether is there any drought conditions, uh, especially in this watershed area from the long run, from the past years, we need to get a long time series more than the 10 years, I guess, and where we could just see the deviation from the mean in the patterns. So over here, we are not seeing too many distinct one except the one in 2011 and 2016, I guess. So so more the time period that's more than the 10-year will gonna be more useful in the future if we really want to find out whether there is any drought the condition of the drought in the near future. So, and I also took the help of the climate engine website just to get the data of the NDVI and EVI. So I used the Jupyter notebook and the Landsat 8 just to get the false color, just to get the representation of this image of the image over here. And I also took the help of the climate engines to get the data just like this. And from this, we can just make a conclusion like, okay, we are not able to conclude a lot where the drought has been happened in the Logan watershed in the last 10 years, all the way from the 2010 to 2020. But if we really want to investigate it in a more long duration of the time, and we can just make the conclusion that the potential drought has happened in the Logan watershed, Logan River watershed. Yeah, thank you. Questions?